Okay, so this question is, it looks simple on the surface, but there's one thing that I'm guessing might be the thing that's tripping you up. If it is, you can just watch this part of the video and then you can be on with your day. You don't have to watch the rest. But if this is the thing that's tripping you up, once you find the force of friction and acting against the object's motion, and you find the component of the force of gravity acting on the object's motion, you can add those together to find the total force acting against the object's motion, which then leads you to find the acceleration of the object back down the slope where it came from. And you may be thinking that you can't find that acceleration because you don't have the mass in the problem. But when you're adding the force of friction together with the force of gravity and you write it all out, the masses actually cancel out and you don't need to use them. And then you can just find the acceleration from there and do your linear equations, blah, blah, blah. The question becomes much simpler. If that's not what you're worried about, then here we go. I'd like to start with writing out all the components that we have. So first, it gives us the initial velocity, 15 meters per second. It also gives us the angle of the slope that the sled is going on, which is 30 degrees. And it gives us the coefficient of friction, which is 0.22. Unwritten here, it says that the final velocity is 0 when the sled comes to a stop here. And also implied is that the acceleration due to gravity is 10 meters per second squared, negative 10 meters per second squared. So once we have all this information, I like to draw a diagram. So we have a incline here, 30 degrees. We have an object on the incline moving forward at 15 meters per second. And we also have the forces acting on it. So there's a force of friction acting opposite to the object's motion, like it always does. And we have the force of gravity acting downwards, straight towards the Earth's core, not perpendicular to the surface of the plane like that, but straight downwards towards the Earth's core. And all right, so in order to find the total force acting on the object, pulling it back down the slope, we need to find both the force of friction and the component of the force of gravity that's acting along with the force of friction parallel to it to find the acceleration going in this direction. We'll start with the force of gravity here. In order to do that, we need to draw another triangle. So what I do is I draw this right here, and that's 90 degrees. Force of gravity is always going to be your hypotenuse in these questions. So if you do the trigonometric rules, and you go through all the angles and everything, you'll find out that this angle right here is going to be the same as this angle right here. So you don't have to go through all the different fancy parallel lines and everything. Just know that this angle in these questions is going to be 30 degrees. So we have the force of gravity on the hypotenuse, we have the angle here, and we're looking for this component right here. In order to do that, we have an opposite, we have a hypotenuse, and we have an angle. So we just write sine. Sine deals with opposite over hypotenuse. So sine of 30 is equal to opposite x over hypotenuse, force of gravity. X is going to equal force of gravity times sine of 30 if we solve for x. All right, so this is the component of gravity that acts along with the force of friction against the object's motion. So we have that. Now we have to find the force of friction. In order to do that, you have to know that the force of friction is equal to the normal force of the object on the object times the coefficient of friction. So the normal force is going to be the component of the force of gravity that's acting perpendicular to the surface of the incline. If the inclined surface is right here, then perpendicular to that will be this line right here. Okay? So if this is the force of gravity, and this is 30 degrees, the normal force is going to be the force exerted upwards right here, which is going to be equal and opposite to this vertical component of the force of gravity. We'll call that y. Right, so we have this is 90 degrees, and just like in the other thing, in the other picture, this angle is also going to be 30 degrees here. So When you're doing the normal force, just know that this angle at the top here is going to be 30 degrees. If you're doing the force of gravity, the component of the force of gravity, you'll know that the angle on the bottom left here or the bottom here is going to be 30 degrees. But moving on from that, we know that this is adjacent to the angle and this is the hypotenuse, so we're going to use cosine this time. So the normal force is going to be equal to force of gravity cosine of 30. Okay, and overall the force of friction is going to be the force of gravity times the cosine of 30. From there, we have the force of friction, we have the force of gravity here. We can just add them together here to find the total force. Oh, I'm sorry, I forgot coefficient of friction here. Remember that. We add the force of friction here, which I wrote out with the coefficient of friction, and the force of gravity here, in order to find the total force acting on the object in this direction when the object is moving in this direction. So now we have the mass times acceleration as the total force. Force is always mass times acceleration. When you have force of gravity, it's mass times gravitational acceleration, which is -10. We plug everything in there. Again, we have force of gravity, so we do mass times gravitational acceleration, sine of 30. And then when we look at this, we see that we have 3 masses in all 3 terms, so we cancel them out, and now we're just solving for acceleration. When you put it into the calculator, you get 6.9052 something something, all of that. Okay. Now the last thing that we need to do is take this acceleration and just use a linear equation of linear motion to find how far the sled has gone up the incline. The linear equation we're going to use is going to be this one. The final velocity squared is equal to the initial velocity squared plus 2 times acceleration times delta x. If you want to solve for delta x, you can. You'll eventually get to this. Okay? Now we're just going to plug in everything that we have. We saw that 15 is our initial velocity, so that's -15 squared. And we have our acceleration, which is against the direction of the velocity, so actually it's going to be negative, sorry. So we're going to have 2 times -6.905 whatever. And when you do that out, you get 16.29 meters. And that's going to be your answer. I hope that helps. Good luck. Thank you very much.